Hello friends, welcome to engineering tutorial. So today we are going to resume our discussion on a new topic. Actually it's not new, but it's been a while since I have posted videos related to this subject. So we are going to we resume our discussion on communication systems. So I've already I think I've posted uh, some basic videos related to communication systems, but it's been a long while. So we will again take up this subject, and I will discuss some things related to this. So like we do with all the other subjects, we'll start with the basics and then gradually move on to the uh, advanced level things. Okay, so communication system, basic concepts related to it. So before we discuss communication systems, we must first understand the basic definition of communication. What is communication essentially? So in simple words, we can say that communication is the process of exchange of information, okay, sharing of information between two parties, between 2 points. And in order to exchange information, we have to establish a connecting link, okay, a communication link. So just when two people talk with each other, they uh, produce some sounds, they use a particular language which is common to both parties, and then the medium of propagation, the connecting link, is air. So the sound waves, it travels from one point to the other, and the other person, he or she understands what the other person is saying. The mind processes the information and then he or she responds. That is the basic form of oral communication. But when we talk about electronic communication, here the information, the data for exchange or transfer or sharing between 2 points, is it has to be in electrical form. So electronic communication data should be in electrical form, that is suitable voltage or current form. So this is what we call as electrical or electronic communication. Okay, so we will be focusing on this aspect, the electrical communication. Yes, it will be uh, the basic things will stay the same, that we have to produce data, we have to send it, but it will happen through electrical means. Okay, so the basic communication process, okay, we can divide it into three main categories. Okay, first is transmission, then is reception, and processing. The processing of the received data, or at the side of the transmitter, while it is before it is being transmitted, we have to process it into a particular, to convert it into a suitable form so that it can be easily transmitted. And then at the receiver side, again it has to be processed, analyzed by suitable signal processing techniques, so that we recover the original message or information without any loss or distortion. So these are the three important parts of the communication process. Now the whole communication system, we can understand it with the help of this block diagram. You will find it in almost everywhere where you will see the basic block diagram of a communication system. You will find this block diagram. So here there are some important elements here, blocks. So here, from this point to this point, this is the transmitter side. or we can say the sender side. Okay, the information source, the input transducer, and the transmitter. Then this is the channel or medium, which is the connecting link between the transmitter or the sender and the receiver. Okay, and then on the receiver side we have the receiver and the output transducer, and then some other circuitry is also there, but here we'll not go into that in detail. In a simplified form we will try to understand. Okay, so first is the information source. Okay, the information source is the data or the message which is to be transferred. Okay, it can be audio, sound, video, image, any number, alphabet, or any kind of a signal. Okay, it can be in analog form or digital form, but mostly nowadays we use the digital communication techniques because it has various advantages over analog communication. So analog and digital communication also we'll discuss in detail, but here you just understand this much, that the information source, it is the data, the information, the message which is to be exchanged, which is to be shared. It can be in the form of audio, video, image, it can be any number, it can be alphabets or any other special characters, it can be anything. Okay, so for example we can say when we speak over the telephone, it is the human voice which is the signal, which is the information, it is an audio signal. Next is the input transducer. Now we all know that this is the electronic communication system, and when we speak over the telephone or anything, it is the human voice, it is a sound signal, a physical signal, basically some kind of a vibrations which is produced. Now for long distance communication, our sound, the vibrations, the sound vibrations, it cannot travel that much distance, and also it cannot be transferred through electrical means. Okay, so for that purpose the sound waves, okay, our voice signal, it has to be converted into electrical form. It is in non-electrical form, we have to convert it into electrical form. So that is the work of the input transducer. Now we have already discussed about sensors, transducers, and the sensors, transducers and instrumentation playlist you can check out. So transducer basically performs energy conversion, converting one form of energy into another, or amplifying it or adding something to it. That is the work of transducer, but basically it performs energy conversion, and the basic definition of sensors and transducers is that it converts non-electrical energy into electrical form. So here basically the transducer which is used in communication, we can say that a basic example is that of microphone. The microphone, it converts human voice into electrical voltage or current signal. Okay, so now the non-electrical sound or our voice signal is being converted into a voltage or current signal, which is electrical form. Now then we have the transmitter after the input transducer. Now the electrical signal which is produced by the transducer, it if we try to just transmit the same signal as it is without making any changes to it, there are high chances that it will not be able to reach, it will not be able to cover the distance between the sender and the receiver. Mostly for long distance communication I'm talking about. So that's why the transmitter is used, which consists of many other sub blocks, okay, various other circuitry, basically a modulator, amplifier, antenna, various other things. which is used to enhance the characteristic of the uh, electrically converted sound signal. Okay, so the modulator amplifier combination, it strengthens the signal characteristics depending on which characteristics it is focused on. It can be amplitude, it can be frequency, it can be phase. So depending on that, amplitude modulation, frequency modulation, or phase modulation techniques can be used. And then the antenna, it converts that electrical signal into electromagnetic waves so that they can cover long distances. Okay, so that is the job of the transmitter. It consists of modulator, amplifier, and antenna, which basically enhance the signal characteristic, raise the strength of the signal so that it can cover long distances. Okay, so transmitter is done. Then we have is the channel or medium. So channel is basically the connecting link between the transmitter and the receiver, as I said. Okay, it connects both of them. Now various types of channels are there, which we can broadly divide it into two categories: wired channels or wireless channels. Okay, wired channels means where there is a physical connection with the help of some wires, cables, or any optical fibers or like that, where there is a physical connection between the sender and the receiver, the transmitter and the receiver. And wireless links can be mobile communication links, satellite links. So various other wireless communication techniques are used, which we'll also discuss. That is also, a separate field in itself: wireless communication, wired communication. So all of these, they are separate fields in itself, separate subjects in itself, which are very vast. So I will not go into that because it will unnecessarily create confusion. So you understand there are two communication channels: wired form, wireless form. Okay, so these are the examples of channels that can be used. Okay, next is, after channel or medium, we have the receiver. So the receiver performs the opposite of the transmitter, what the transmitter does. Okay, so the receiver, it consists of a receiving antenna, a demodulator, amplifier, and filter, the sub blocks. So the receiving antenna picks up the electromagnetic radiations which contain the original message signal. Then the demodulator extracts the original signal from the modulated signal. Remember, in the transmitter side we had modulator, amplifier, and antenna. In the receiver side we have a receiving antenna, demodulator, and amplifier. So the demodulator extracts the original message signal using various demodulation techniques: amplitude, frequency, or phase demodulation. Then as the signal has traveled a long distance, there will be some loss in its characteristics and loss in its strength. So the amplifier again enhances those characteristics, raises the strength of the signal. Okay, the weak message signal, after it has covered a long distance, the amplifier at the receiver side strengthens its characteristics. And then, because of the communication channel, it is prone to noise, distortion, and interference. A filter is there at the receiving side which removes any unwanted noise and interference signal which can produce distortion. Okay, a change in the characteristics of the original signal, thus improving signal efficiency. So this is the job of the receiver. Now the output of the receiver is an electrical signal, okay, which is still in voltage or current form. But at the transmitting side or the sender side, the original signal was the voice signal. But here at the receiver side, we are getting a electrical or the voltage or current equivalent of that voice signal. So again we have to use another output transducer so that the electrical signal can be converted into its original form, which is the sound signal, the voice signal. Because we cannot understand, suppose someone is talking over the phone, and at the receiver side you get some you have a screen, and there some waves are displaying certain changes in the amplitude, frequency or phase of the waves. You will not be able to understand anything, okay, you will not be able to interpret anything, but it has to be converted into the original sound signal. Only then you will be able to understand what the information is. So if it is in the electrical form, we will not be able to interpret the information. So it has to be converted into its original form, which is the sound signal, the voice. We want the voice, not the electrical equivalent of the voice. At the receiver side we get the electrical equivalent of the voice, which is a voltage or current signal. So the output transducer, it converts that electrical equivalent into the original voice signal. So an example of that is loudspeaker. It converts the electrical signal into voice, okay, vibrations. Now another thing which is important here is the noise and distortion. So in any communication channel there will be noise interference components, and we cannot do anything to completely eliminate that. We can regulate it, we can minimize it, we can use various techniques to minimize its effects, but we cannot completely eradicate or eliminate the effects of noise and distortion interference. So any unwanted or undesirable disturbance which can cause error or change the shape of the original signal waveform, that is called as noise. Now it can be due to natural sources or man-made sources or any other sources because of the characteristics of the channel, okay, depending on whether wired or wireless channels we are using. So any channel that we use, for example, let's say we use copper cables or twisted pair cables or coaxial cables, it has its own effects, noise and interference effects. So depending on that, we they have their own advantages and disadvantages. So we will discuss about that when we discuss the communication channels in detail. So noise is any undesirable, unwanted signal which can mask the original signal and cause a change in its characteristic features. Okay, so that is called as noise or distortion or interference. So this is the basic discussion related to the communication system with respect to its block diagram. Okay, hello friends. So previously we just discussed about the basic block diagram representation of the electronic communication system and some basic concepts related to it. Okay, so we discussed about the basic elements of the communication system in terms of the information source, the input transducer, the transmitter, the channel, receiver, output transducer, everything. So in this video we will be focusing on this first block, which is the information source, which is the core or the reason why we are discussing all these things, because information has to be transferred from one point to another. Data is to be exchanged, it is to be shared. So when we say information, okay, when we say information, it actually from the point of view of electronic communication, what information is it is basically a signal which carries the required data or information. Okay, so the data can be present in one of the signal characteristics. Okay, it can be in the form of amplitude change, it can be in the form of frequency change, or it can be in the form of phase change. And also suitable patterns of signal can also represent information. For example, repetition of a particular waveform one after another in a suitable pattern it can convey something, or there are various forms of encoding techniques, okay, that are used for various purposes, which is used mostly in digital communication, okay. Encoding techniques are used, so like that. So when we say information in the point of view of electronic communication, we are basically talking about a signal which is carrying the data in one of its signal characteristics, be it amplitude, frequency, or phase. So some important information sources in electronic communication system, which is generally transmitted when we say information, they can be in the form of audio, just speech, voice signal. It can be picture, it can be music, it can be video, or it can be any other computer related data. So this computer related data is very important because a separate field is there, which is data communications and computer networking. So it is a separate subject, and I've also discussed a lot of things related to data communications and computer networking. You can check out that playlist. So these are the basic information sources. So before discussing them, we must first understand what is signal. So a signal is basically a function of one or more independent variables, okay, such as time, space, and in one of those, the function itself, it carries the data or the information which has to be transmitted, okay. The signal, it can be a function of time, it can be a function of temperature, pressure, whatever. So when we discuss about sensors and transducers, okay, communicating sensor data, depending on the type of sensor, be it a temperature sensor, pressure sensor, or any other humidity sensor, the information which it transmits, it is a function of that variable, okay. Temperature sensor will transmit temperature related data, pressure sensor will transmit pressure related data, humidity sensor will transmit humidity related data. So it can be a function of one or more than one variable. So basically it is a function of that whole thing with respect to time, its variation with respect to time. In terms of that, we generally deal with signals. When we visualize a signal, it is basically a function on the y-axis and its variation with respect to time on the x-axis. We visualize it in that way. So but for electronic communication, the signal, it must be in the form of voltage or current. So that is the job of the input transducer. So we have already discussed that. But mostly when we say signal, it is a function of that particular variable, the parameter which is being measured or which is to be conveyed with respect to time, that we say. So a signal can be one dimensional, for example speech, music, or any other computer related data, such as text, numbers, alphabets, special characters, whatever. Then two dimensional, which is picture or image related information, and three dimensional, which is video signals. So a signal can be from anything, okay. In biomedical field, we can transmit various body parameters related data. For example, this is a typical ECG signal, electrocardiogram signal. There can be an electromyogram signal, a EMG waveform, it looks something like this. Then it can be a electroencephalogram waveform related to brain patterns, brain functioning, various types, alpha, beta, delta, theta. So we have already discussed this in biomedical instrumentation. Then also we can transmit various other natural phenomena data, such as earthquake vibrations, okay. Earthquake waveform, typical earthquake waveform, it looks something like this. So there can be a wide range of information that can be transmitted, and the basic requirement is that they have to be converted into electrical form. So it can be of any type, okay. The information source can be of any type. So here we'll be discussing some basic things, okay, that constitute the information source. So speech and music. So Speech is the transfer of information from the speaker to the listener in a language which is common to both parties. So it involves three stages: production of the voice by the vocal cords, then its propagation, and perception, how the other person interprets the information and responds to that. So a typical speech signal looks something like this. It's a little bit compressed, but it looks something like that. And another form, which is the music, it is a sound signal which is produced from, it can be uh, human voice or from instruments, and it can be a melodic structure or harmonic structure. So a melodic structure, it consists of a sequence of sounds that are timed, but harmonic, it consists of a set of sounds that are produced synchronously, okay, or at the same time. And then we have the picture and video signals. So as picture is two-dimensional and video is three-dimensional. So picture or image signal, it involves suitable frames capturing the scenes consisting of various colors of varying intensity, brightness, and other features, which we have already discussed in television engineering. You can check out there, we have discussed in detail related to this various image characteristics. You can check out that playlist related to television engineering. So picture, it can be static or dynamic, okay. Static picture frame is the picture frame which is a still, okay, a still picture. Dynamic picture is what we call a video, okay. So the static picture, the photographs which are taken by the camera, the still frames, the dynamic ones which are produced on the TV screen, okay, the movable frames or videos. So a video signal, it looks something like this. And then we have the computer related data, okay, which is the information which is processed, analyzed, and stored by a computer. And there is a whole subject which is dedicated to it, which is data communications and computer networking. So the data which is computer related data which we are talking about is uh, which is in bulk form, okay. It can be text, numbers, images, audio, video. It can be in the form of integer, floating point, character, string, boolean data, special characters. So it can be anything. So these are the some of the examples of information which are used in the communication system. So there is a wide range that we can cover here, but here we just discuss some basic things related to it, okay. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science, and technology. Have a great day. Thank you very much.